In this illustration, we'll discuss about the oscillations of a triangular wedge. Here the figure shows a wedge block of mass m placed on a smooth surface and kept in contact of two unattached spring of force constants K1 and K2. Here we are given that if springs are constrained to deform along length only, we are required to find the period of small oscillations of wedge on horizontal plane. Here in this situation we can first find out the deformation in a spring K1 when the wedge moves, because when it goes toward right, the oscillations of wedge with respect to K2 spring will have angular frequency root of K2 by m. But when it is displaced toward left, here we can see if this dotted position represents the earlier position of wedge where it is displayed toward left by x, then we can see this spring, which is of force constant K1, will get deformed by a length y. So if this angle is theta, this distance is x, so here we can write y is equals to x sine theta. So we can write if wedge moves toward left by x, deformation in a spring is this y we can write as x sine theta. So this spring will exert a restoring force onto the wedge in this direction F1. This implies a spring force on wedge is this F1 we can write as kx sine theta. So in this situation, the force with which wedge will be moving toward right will be F1 sine theta, due to which the wedge will be experiencing a restoring acceleration. So here we can write for wedge, we can write kx sine theta. Sine theta is equals to ma1 if a1 is the acceleration with which wedge is moving toward right. So here the value of a1 we can see this k1 sine square theta by m multiplied by x. Again we can put a negative sign for restoring nature, or because a is opposite to x. So here we can write if a1 is given as this, comparing with minus omega square x or omega 1 square x. Here we get the value of omega 1 as root of k1 sine square theta by m. And obviously for deformation of right spring, we can write the angular frequency omega 2 as root of k2 by m, and half oscillation of wedge is in the influence of one spring and half in the influence of other spring. So we can simply write the time period of oscillation as t is equals to pi by omega 1 plus pi by omega 2, which is pi root of m by k1 sine square theta plus pi root of m by k2. That will be the final result of this problem.